After the solid rocket boosters propelled the space shuttle into orbit, the twin SRBs would splash down in the ocean to be picked up by 2 waiting recovery ships. Those boosters would be brought back to NASA's Assembly and Refurbishment Facility, or ARF. With the shuttle program over, the newly renamed Booster Fabrication Facility is preparing those same shuttle booster segments to help carry NASA's Space Launch System. Spaceflight Insider's Jason Ryan got a look at why the BFF really is a solid rocket booster's BFF.
This building was built and completed in 1986, occupied for the purpose of building all of the non-motor major assemblies and systems and subsystems for the Space Shuttle Solid Rocket Booster. We are now using it to build those same assemblies for the Space Launch System booster.
Has the building that we're in right now, has it been changed any or a lot since the shuttle days?
Not a bit, actually. It has stayed the same. No modifications per se, some upgrades because it's been around and been in use since 1987.
Really?
And so we've done some upgrades, some facility updates, if you will, but primarily it has stayed exactly the way it was for shuttle. We're still using all the same ground support equipment, facility equipment to process the SLS booster hardware.
Now, that's a great segue point right there, because while the building may not have changed, y'all's mission, as in terms of where your vehicle is going to be going, has changed from LEO to beyond Earth orbit, and I'm sure that a lot of changes have been made to these segments. Can you tell us a little bit about what we're seeing back here? Sure.
What's behind you is what we call the Frustum, and it's on the very top of the booster. As indicated in this graphic here, it's located right there. Behind me is a forward skirt assembly, and it's right between the Frustum and the forward motor segment of the booster.
That off-white kind of beige little segment right under that.
That's correct. That's the forward skirt. And what you're seeing is the structure itself, which is aluminum in both cases, and they're simply primed. We will be preparing these for flight. This Frustum is for EM1's left-hand booster. And we will be top coating them with white paint, similar to the F-skirt we just looked at, and then applying what we call thermal protection system on top of the paint. And it's a material that's used to maintain temperatures within the structure below the required limits. And it's same material that we flew on Space Shuttle, same thermal protection system material that we flew on Space Shuttle. What you're seeing here behind me is the Ares 1X aft skirt. This flew on the Ares 1X test flight back in October of 2009. Again, the aft skirt is the bottom of the entire booster. This right here is what we call the hold down post, and it's what carries all the load of the vehicle when it's sitting on the mobile launch platform. So the entire weight of the launch vehicles is put through these 4 posts. So on Space Launch System, there's 2 of these skirts, but when Ares 1X flew, it was what we call a single stick booster, and it was just the one tall, skinny booster. You can see the remaining thermal protection system material here. We've left it on, haven't taken it off. The darkened area is the results of the thermal heating that the vehicle saw on ascent and re-entry. The majority of the heating is during re-entry. We've installed some booster separation motors, as we call them. They were not there like that on Ares 1X, but they're in the configuration that they will be for Space Launch System. We did this to do some process enhancement verifications, because we're making some changes to the TPS that you see on the nozzle, and so we did this as a check to make sure that it was going to work properly and that the technicians could in fact apply it in the time that was required. And that all came out very well, so we're moving on with applying that same process on the SLS aft skirt booster hardware.
You also told us something a little behind the scenes, and we're going to talk about it. Of course, space fans, and we're of course one of them, notice that you've got this really cool swoosh and artistic license going on here. But that's not probably going to fly on EM1, is it?
I believe that right now is being discussed. It hasn't been finalized. They're trying to decide whether to do that or not.
That'd be really cool if y'all did that.
Yeah, it would look neat.
The shuttle didn't have that, so
No.
can you tell us a little bit about the differences going down that line between what these were like on shuttle as compared to what they will be like for the EM1 boosters on?
Sure. So the Frustum, its primary mission during Space Shuttle was to house the 3 main parachutes. As you know, on Space Transportation System, or Shuttle, we retrieved the boosters in the Atlantic Ocean and de-aerated them, floated them like a log, and brought them back to Kennedy Space Center, where we refurbished them and flew them. This Frustum that you see flew 13 times on Space Shuttle. The Frustum's unique in that it can be used on a left-hand booster or a right-hand booster. So this is flown in both locations. For SLS, there are no parachutes. We're not retrieving the boosters. They're just going to splash. So there will not be any parachutes inside the Frustums for SLS.
Now, is that space going to be used for anything else? Or?
No, that space will just be wide open. There will be some development flight instrumentation in this area, as well as the whole entire booster. The forward skirt you see here is not going to fly on EM1. It will fly on a later mission. It has been significantly modified inside in that we've added some structural strength to it with stiffener webs, which is required for the additional loads as a result of SLS being a 5-segment booster and a much heavier vehicle.
Now that's a great point. Sorry to interrupt, but Shuttle was 4 and SLS is going to be 5. So can you talk a bit about some of the implementation and integration processes you guys have had to go through to go from 4 to 5, and the changes you've had to make to, of course, make these segments for use on Shuttle for use on SLS?
And well, the most significant thing is, of course, the motor segments for SLS, being that we now have 5 segments. And the most significant thing has been the qualification motors that we have done. Most recently in June of this year, qualification motor number 2, which was our cold motor test. And last March, we did qualification motor number 1. Those are the most significant changes for the SLS booster. But there are additional changes that are not as obvious, in that for the forward skirt, we have a whole new avionics system that's totally different than it was on Space Shuttle. We will be battery powered for SLS, as opposed to in Shuttle, we got our power from the fuel cells on the orbiter through the external tank into our booster. A new range safety system, or as we refer to it, the flight termination system, all different than it was on Shuttle. So all of those components are going through qualification now for use on SLS, since they weren't used on Space Shuttle.
Probably one of the things that we've asked more times than anything else, because Spaceflight Insider is focused on giving the information to the public, is your work here and the work of the team that you represent here is pivotal to getting humanity back on the road to deep space exploration. So you're talking to the public. What do you think is the most important thing the public should know about Orbital ATK's work here at the BFF?
And I would say that the most important thing about the work we do here at the BFF is the dedication of the people to make this happen. We have a core group of folks that were here and worked in this facility and on these structures and systems during Shuttle, and we have a significant amount of new personnel who are now learning it. So there's a transition there to build a team that's the older, wiser folks, if you will, and the younger, eager to learn, ready to go make some changes. To me, that's the most significant thing that's going on here at this facility, is that total integration of the personnel, and every one of them is totally dedicated to do what they do here, and more than anxious to build this thing and watch it launch.